Hi guys, welcome to this Easy Maths video. Today we're looking at the 2019 Intermediate Maths Challenge, questions 11 to 20. Question 11, which of the following is equal to 3 to the power 9 divided by 9 cubed? We got answers as A is 3, B is 9, C is 27, D is 81, or E is 243. Okay, so the first thing we can do is we can rewrite 9 cubed as 3 squared all to the power of 3. Now, using our law of indices, if we've got a power inside a bracket and a power outside the bracket, we can multiply the two powers together. So we get 3 to the power of 6. So 9 cubed is the same as 3 to the power 6. So now I can rewrite 3 to the power 9 divided by 9 cubed as 3 to the power 9 divided by 3 to the power 6. And now I'm using my law of indices. If I'm dividing by two numbers which have the same base but they have different powers, I subtract the powers. So I'm going to have 9 minus 6, which is 3. So that's 3 to the power of 3. And I know that's 27. And I've got an answer for 27, which is answer C. So therefore, my final answer equals C. Question 12. The game of Raw Room 2 is played on a 4x4 board starting with a counter in one corner as shown. At each turn, the player moves the counter to a cell that is a reflection of its current cell in one of the 6 dashed lines. How many cells could the counter occupy after precisely 3 turns? We got answers as A is 4, B is 6, C is 8, D is 12, and E is 18. Okay, so let's think about all the positions in which this counter can move to. So after one turn, the counter is reflected in each of these dashed lines. So that means if I represent where the counter can move with the number 1, which represents the first turn, so it can move here, here, it can move here, and it can move there. So that's all the positions that it can move in after its first turn. Then let's say it moves to this position here. Okay, so on its second turn, it can move here, 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 and also move here. If it ended up moving to this position, then the counter can move here and here. And then we could also have this counter, which could move to this position. And I think that's all of our possible positions. Now let's see after the third turn where the counter could move. So let's say we start here. The counter can move here, could move here, and then it can also move where these 1s are. So I'm going to replace these with 3s. Let's have a look at this 2. Well, a 3 can go here. I think that's it for that one. If we have a look at this 2, 3 can be reflected here where the 1 is. If we have a look at this 2, we can replace this 1 with a 3. And then if we look at this 2 here, this can be a 3. And I think that is all of our positions. So if we count up the number of 3s, we've got 1 here, 2, 3, 4, 5, 6, 7, 8. The total number of cells that the counter can occupy after 3 turns is 8. We've got an answer for 8, which is answer C. So therefore, final answer equals C. Question 13. The mean of her first 3 numbers is minus 3. The mean of her first 4 numbers is 4. The mean of her first 5 numbers is minus 5. What is the difference between her 4th number and her 5th number? We've got answers as A is 66, B is 55, C is 44, D is 33, or E is 22. Okay, so if we represent these first 5 numbers, the letters A, B, C, D, and E, well, we know that the mean of the first 3 numbers is going to be A plus B plus C, all divided by 3 equals minus 3. So we multiply both sides by 3, we're going to get A plus B plus C equals minus 9. Okay, and the mean of her first 4 numbers is 4. So A plus B plus C plus D, all divided by 4, is going to equal 4. So that means A plus B plus C plus D will equal 16. And the mean of her first 5 numbers is minus 5. So that's A plus B plus C plus D plus E, all divided by 5 equals minus 5. So that's A plus B plus C plus D plus E equals minus 25. Okay, and we need to find the difference between her fourth number and her fifth number. Well, her fourth number is the letter D and her fifth number is the letter E. So using this equation here, the A plus B plus C plus D equals 16, we can replace A plus B plus C with minus 9, and then plus D, that's equal to 16, so we can rearrange this to find D. So if we add 9 to both sides, we get D equals 25. So that is our fourth number. And then we can use this equation, A plus B plus C plus D plus E equals minus 25 to find the value of E. Well, we know A plus B plus C plus D is 16, so we can say that 16 plus E equals minus 25. And if we subtract 16 from both sides, we get E equals minus 41. So 25 is the fourth number, D, and E is the fifth number, minus 41. So the difference is going to be 25 minus 41, which becomes plus 41, which gives us an answer of 66. And we've got an answer of 66, which is answer A. So therefore, our final answer equals A. Question 14, there are 4 people, some of whom always tell the truth, the others always lie. First person said an odd number of us always tell the truth. The second person said an even number of us always tell the truth. The third person said a prime number of us always tell the truth. And the fourth person said a square number of us always tell the truth. How many of these 4 people were telling the truth? We got answers as A is 0, B is 1, C is 2, D is 3, or E is 4. So, if we have a look at these first 2 statements, first person says an odd number of us always telling the truth, and then the second person says an even number of us is always telling the truth. Well, we know that an integer cannot be odd and even. It has to be one or the other. So what we can say is we can make the assumption that one of them is telling the truth. Okay, so whether that's the first person, whether that's the second person. We can look at what the third person and the fourth person said. Well, the third person said a prime number of us always tell the truth, and the fourth person said a square number of us always tell the truth. Well, a square number is not a prime number, and vice versa. A prime number is not a square number. So that means only one of those 2 statements can be true. Now, let's say one person was telling the truth. Okay, well, if one person was telling the truth, 1 is an odd number. So the first person's statement would be true, and 1 is also a square number. So the fourth person's statement is also true. But that means 2 people are telling the truth. So that means we've got a contradiction. So it definitely can't be 0, and it definitely can't be 1. What if we say 2 people are telling the truth? Well, if 2 people are telling the truth, then an even number of people are telling the truth, so the second person is telling the truth. And then the third person says a prime number of us are telling the truth. Well, 2 is a prime number, and that would mean that the second and the third person are telling the truth. So therefore, our answer must be 2, which is answer C. So therefore, final answer equals C. Question 15. The diagram shows 6 congruent equilateral triangles of side length 2 placed together to form a parallelogram. What is the length of PR? Got answers as A is 2 root 13, B is 7, C is 6 root 3, D is 9, and E is 7 root 3. So obviously equilateral triangles have equal side lengths. So we can say that this is going to be of length 2, this is going to be of length 2, this is going to be of length 2. So the total length here is 6. Okay, we're trying to find this distance here, PR, the length of this diagonal. Okay, so the first thing that sort of came into my head was trying to use Pythagoras. Okay, now you're probably going to see here that because this is a parallelogram, we don't have a right angle here. But let's just pretend we can make a right angle. So what we could do is we could add another triangle at the end of here, which would be a right angle triangle. Now, this right angle triangle, if you think about it, a right angle triangle is half of an equilateral triangle. So that means the base would be 1, and its height, well, we can figure out its height, we'll work it out. Because if we draw this triangle, we know that the hypotenuse is 2, we know the base is 1, and then using Pythagoras we can work out this length here, the height. So it's going to be square root of 2 squared minus 1 squared, which is root 3. Okay, so the height is root 3. So remember, parallelograms have parallel side lengths which are equal. So this length here is going to be 6. So the total length of this base is going to be 6 plus 1, which is 7. Can you see I've got a right angled triangle here with a base of 7, a height of root 3, so I can find out my length of PR by using Pythagoras. So we can say PR equals the square root of 7 squared plus root 3 squared. 7 squared is 49 and root 3 squared is 3. So that simplifies to root 52, and we can simplify root 52. 13 times 4 is 52, and the square root of 4 is 2, so we get 2 root 13. And we've got an answer of 2 root 13, which is answer A. So therefore, final answer equals A. Question 16. Two numbers x and y have a product which is equal to their sum. Which of these expressions gives x in terms of y? We've got answers as A is y over y minus 1. We've got B is y over y plus 1. We've got C is y plus 1 over y. We've got D is y minus 1 over y. We've got E is y squared over y plus 1. So the product of x and y is going to be x times y, and that is equal to the sum of x and y, which is x plus y. So now what we need to do is we need to basically rearrange this equation. So we've got x as our subject, and then our equation is in terms of y. So how can we do that? Well, what we can do is we can subtract this x from both sides. So we get xy minus x equals y. Now we want x as our subject, so we can factorise x from the left hand side. So we get x all multiplied by y minus 1, and that's equal to y. And now we just need to divide both sides by y minus 1. So we get x equals y over y minus 1. So we've got x as our subject, and the equation is all in terms of y. And we've got an answer for y over y minus 1, which is answer A. So therefore, final answer equals A. Question 17. Which of these is equal to 0.8 recurring plus 0.07 recurring? We've got answers as 0.87 where the 7 is recurring. We've got answer B, which is 0.88. Answer C, which is 0.95 where the 5 is recurring. Answer D, which is 0.96 where the 6 is recurring. And answer E, which is 0.98 where the 8 is recurring. Okay, so the way I thought about this is we obviously know that recurring decimals have an infinite number of decimal places. They recur forever, okay? So what I thought is let's write 0.8 recurring in an expanded form. Let's sort of treat it like it's finite. So if we do the same for 0.07 recurring, so this 7 is going to keep on recurring infinitely. We're going to sort of make the assumption that it stops. So now, if I add these together, starting from the right hand side, we're going to get 8 plus 7, which is 5, carry the 1, 8 plus 7 plus 1 is 6, carry the 1, so we're going to end up getting 6. Okay, and then we carry this one forward and we get 8 plus 1, which is 9. Now, what you should be able to see here is we've got 0.966666665. Okay, but like I said, I treated the 0.8 recurring and the 0.07 recurring as two numbers with finite decimal places. So what's going to happen is I'm not actually going to end up with a 5 here. I'm going to end up with a 6 here, because that 6 is what keeps on recurring. So that means if I'm going to write this in a recurring decimal format, it's going to be 0.96, where the 6 is recurring. We've got an answer for that, which is answer D. So therefore, final answer equals D. Question 18. Two numbers x and y are such that x plus y equals 2 over 3 and x over y equals 2 over 3. What is the value of x minus y? We've got answer A is minus 2/3, answer B is minus 2 over 15, answer C is 2 over 25, answer D is 2/5, answer E is 2/3. Okay, so we've basically got a simultaneous equation here in which we need to find the values of x and y and then just work out their difference. So this is equation 1, this is equation 2, so if we rearrange equation 2, so we've got x as a subject, so we multiply both sides by y, we get x equals 2/3 y. Now I can substitute the second equation into the first equation by replacing x with 2/3 y. So I get 2/3 y plus y equals 2/3. Now 2/3 of y plus y is the same as 5/3 of y. That's equal to 2/3. I can then solve for y by multiplying both sides by 3. So I get 5y equals 2, and then dividing both sides by 5, I get y equals 2/5. Okay, and I can easily work out what x is now, because I can use this equation up here, which is x equals 2/3 y. Replace y with 2 over 5, so I get x equals 2/3 multiplied by 2/5. That gives me 4 over 15. And now I need to find the value of x minus y. Well, the value of x minus y is going to be x, which is 4/15, minus y, which is 2/5. Well, what I can say is I can use a common denominator of 15. So I can replace 2 over 5 by multiplying both my numerator and my denominator by 3. So I get 6 over 15. And then I get 4 over 15 minus 6 over 15, which is minus 2 over 15. And I've got an answer for that, which is answer B. So therefore my final answer is B. Question 19, which of these expressions has the largest value? Got answers A, B, C, D and E. Okay, so if we start by looking at each of the values, so we know A is a half, which is equal to 0.5. Okay, and B is a third plus a quarter. Now, common denominator of a third and a quarter is 12. So we can convert a third into 4 over 12, and a quarter can be rewritten as 3 over 12. So we get 7 over 12. Now 7 over 12, what is that as a decimal? Well, we know 6 over 12 is a half. So 7 over 12 is going to be greater than a half. So what we can say is that 7/12 is greater than a half. Okay, now let's look at C. Well, C is a quarter plus a fifth plus a sixth. Now the common denominator of a quarter plus a fifth is going to be 20. So we can rewrite a quarter as 5 over 20, and we can rewrite a fifth as 4 over 20. And that simplifies to 9 over 20. And then we've got to add 9 over 20 to a sixth. Now 9/20ths plus a sixth is going to have a common denominator of 120. So it's 6 times the 20. So the common denominator is going to be 120. So numerator is going to be 9 times 6, which is 54, plus 1/6, which can be rewritten as 20 over 120. So that simplifies to 74 over 120. Well, I know that 70 over 120 is going to be the same as 7 over 12. So that means 74 over 120 is greater than 7/12. So we can say that 1/4 plus 1/5 plus 1/6 is greater than 7/12, which is greater than a half. Okay, and now you should start to see a pattern here. Because what's happening is, if we look at D, the first fraction is getting smaller, so we've gone from a quarter to a fifth, but what's happened is the number of fractions that we're adding has increased by 1. So we started off with 1 fraction for A, 2 fractions for B, 3 fractions for C, 4 fractions for D, 5 fractions for E. And what ends up happening is each of these values keeps on getting larger. So using that logic, that means E is going to be our largest value. So therefore, final answer equals E. Question 20. Three equilateral triangles with side lengths of length 1 are shown shaded in a larger equilateral triangle. The total shaded area is half the area of the larger triangle. What is the side length of the larger equilateral triangle? The answers is A is root 5, B is root 6, C is 5 over 2, D is 3 root 3 over 2, and E is 1 plus root 3. Okay, so each of these smaller shaded triangles are equilateral triangles which have side lengths of 1. Okay, and we're told that the total area of those three triangles is half the area of the total triangle. So if we work out the area of one of these triangles, so if I draw it, now this equilateral triangle can be split into two right angle triangles. So that's going to have a base of half, that's going to have a base of half, and these are going to have side lengths of 1. So we can work out what the height of this triangle is going to be by using Pythagoras. So we can say that the square root of 1 squared minus a half squared is 1 minus a quarter, which is the square root of 3 quarters. So that simplifies to root 3 over 2. Okay, so that's our height. So that means the area of that whole triangle is going to be a half times base. Well, total base is 1 and our height is root 3 over 2. So that simplifies to root 3 over 4. Now, there's 3 of these triangles, so we can multiply root 3 over 4 by 3, which gives us 3 root 3 over 4. And then we're told that the area of those three triangles is half the area of the larger triangle. So the area of the total triangle is going to be twice 3 root 3 over 4. So we do 3 root 3 over 4 times 2. That's 3 root 3 over 2. Now, what's happening is if we draw another equilateral triangle, and let's say we're trying to find the side lengths, so let's call these side lengths x. Okay, well, we can work out the height the same way we worked out the height previously using Pythagoras. So we could do the square root this time of x squared minus x over 2 squared. Now that simplifies to x squared minus a quarter x squared, which is 3 quarters x squared. So that simplifies to root 3 over 2x. Okay, so that's the height. If I call that h, that's the height of our equilateral triangle. So the area is going to have base of x multiplied by the height, which is root 3 over 2x, multiplied by half, and that's going to equal the area that we calculated, which is 3 root 3 over 2. Now this simplifies to root 3 over 4 x squared, and that's equal to 3 root 3 over 2. If we multiply both sides by 4, we get root 3 x squared equals 6 root 3. And then divide both sides by root 3, we get x squared equals 6. And then square root both sides, we get x equals square root of 6. Now technically this would be plus or minus root 6, but we're not going to have a negative length, so the answer must be root 6. Got an answer of root 6, which is answer B. So therefore, final answer equals B. Thanks for watching the video, guys. Don't forget to subscribe to my channel. I've also left a link in the description to my website, and you can also check out any other videos from my YouTube channel on this page.